Hello, my name is Chongwon. In this video, I will demonstrate my ray tracing program. The program loads 2D parts into a 3D scene, computes shadows and reflections, and renders the final image. Here is the final rendered image. You can see shadows cast by objects and reflections on surfaces. The background colors is slightly adjusted based on depth. This concludes part 1, demonstrating the project learning and its visual effects. At the start of rendering, I print loading to indicate that the ray tracing process has begun. After the image is saved as a PNG, I print PNG saved to notify that the progress is complete. Here, I define a method to add two vectors. It takes another vector, v, and returns a new vector with each component added. This is useful for slightly offsetting points to prevent self-interactions when casting rays. Next, I define the light source at position 5, 10, 0. I calculate our vector from the interaction point to the light and also the distance to the light. This will help determine if a point is in shadow. I then create a normalized direction vector and a shadow ray pointing toward the light. Then I loop over all the triangles in the scene to see if the shadow ray intersects any object before reaching the light. If it does, I mark the point as in shadow. If the point is in shadow, I return a darker color. Here, I choose a subtle bluish tone. Finally, for surfaces not in shadow, I blend the reflected color with a base color. I use a 50% reflection factor for each channel. If no intersection occurs, I return a background color.